Welcome back everyone. So today I brought another nice problem from electrostatics chapter. It's also from supernova physics book, and this problem is basically on flux calculation and application of Gauss law. So let me read out the problem once. The problem states that a point charge q is kept at the center of circular plane surface of cone. A shaded section ABDCA as shown at the slant surface of the cone. Yeah, they have shown also here. This is the ABCDA surface, right? And if the electric flux through the shaded section is n upon m times q by 8 pi epsilon naught, where n and m are minimum possible integer, find n plus m, and AB length is given in terms of h as h by 2. And all the other dimensions and angles are shown in the figure. We'll use this data as well, right? So let's proceed to the solution. Yeah, first I have drawn only this frustum portion, this portion, right? I'm marking with green color, so only this portion I have drawn here. So this is that frustum portion, and here was the charge q given. The upper circular face joining the edge of the upper circular face to the point q was subtending an angle of 53 degree with the vertical line, and the lower circular face was subtending 37 degree. All these were given, right? So I have done one calculation here with the blue color. I have shown that I have determined the radius of that upper cross section in terms of h using simple trigonometry. We can do that. This one is r, this is h given, and this angle is also given 53 degrees, so r comes out as 4h by 3. I have done this because we'll need the value of radius of that cross section later on, right? So you will understand why we will need this value. So let's keep it aside first. Now I will try to calculate. So we are supposed to calculate the flux through ABCD. So let me tell you the roadmap. I will first try to calculate the flux through the green marked frustum, this whole frustum. And as this is a uniform case, the flux distribution will be uniform. So we'll just claim that whatever be the certain fraction of that total frustum passing through that cross shaded portion, we'll tell that as our answer, right? Because we are given the AB length, right? Yes, AB equals to h by 2. Now you can understand, I think, why I have determined the radius r. Because I will calculate the total flux through these curved surfaces and multiply that with AB upon 2 pi r. Why? Because 2 pi r is the total circumference of that upper cross section, and this shaded portion is subtending AB length of that cross section. So this fraction should be multiplied with total flux through the curved surface of that frustum. That is our purpose, and that's why we have found out the radius r in terms of h. So to do that, we will first calculate the flux through all the surfaces of this frustum. We are interested in phi 3 obviously, but we can't determine phi 3 without the help of phi 1 and phi 2. Phi 1 I have assumed that the incoming flux through this upper circular cross section, and phi 2 is the outgoing flux through that lower circular cross section, right? So obviously, as per our convention, for incoming flux we will use negative sign, and for outgoing flux we will use positive sign. So phi 1 will be q upon epsilon naught is the total flux as per the Gauss law. For a charge q, we will get total flux q by epsilon. But obviously the total flux will not pass through this circular cross section. Only a fraction of it will pass. So we'll use the concept of solid angle, and I think you know this very well, right? I'm showing it here as well. If this is a circular cross section and this is a q charge placed here, and it will obvious if we join the q charge to the edge of that circular portion, we will get a conical shape, and if the semi-vertical angle of that cone is theta, we claim that the solid angle subtended by this plane at the point where q is placed is 2 pi times 1 minus cos theta. So we'll use this result as well. So I've used this result here as solid angle subtended by that circular cross section is 2 pi 1 minus cos 53 degree. This is the solid angle of the plane subtended, and 4 pi is obviously the total solid angle. For any point, a closed surface will subtend a solid angle of 4 pi around that point, right? So this one is the fraction, sorry. So this one is a required fraction. This fraction of total flux will pass through the required plane, and that is our phi 1. So phi 1 comes out as minus q upon 5 epsilon naught, putting all the values of cos 53 degree and all. Similarly, we will calculate phi 2. As it is outgoing flux, we are having a positive sign, and q by epsilon naught is obviously the total flux, and again we will calculate how much fraction of this total flux will pass. So yeah, using this idea we can claim that solid angle subtended by this plane is 2 pi into 1 minus cos 37 degree, and 4 pi is the total solid angle. So putting all the values, we will get q upon 10 epsilon naught as phi 2. Now this whole frustum is not containing any charge inside, right? Q inside is 0. One charge is placed outside this frustum, okay? So obviously the net flux through this frustum will be 0. So we can claim that phi 1 plus phi 2 plus phi 3 will be equals to 0. And phi 1 value and phi 2 value we have already calculated. Phi 1 is minus q upon 5 epsilon naught, and phi 2 is q upon 10 epsilon naught. So I have put these values here and calculated phi 3 as q upon 10 epsilon naught. Okay. So half of the solution is done. I think I have already told you that we will do this one is phi 3. Phi 3 is the flux to the curved surface of the frustum, and we will multiply it with AB upon 2 pi r. I'll also explain the logic again. I have shown a rough diagram here just to give you a preliminary idea that all the electric field lines will symmetrically go outside this curved surface. So flux distribution will also be uniform on the curved surface. So phi ABCD, actually this green marked portion out of the total frustum, is our required answer. We are supposed to find that only. So we'll do that by phi 3 times AB upon 2 pi r, where AB is h by 2 given, and 2 pi r, because of this purpose only we have calculated r in terms of h. R was 4h by 3. So this is 2 pi r terms, and this is the AB term, and phi 3 was q upon 10 epsilon naught. So putting all, I think this is clear, right? I have already explained, so I haven't spent much time here again telling that this one is the total circumference 2 pi r, and a required plane ABCD is subtending a portion AB from this circumference length. So this one is the required fraction of total flux phi 3 that will pass through ABCD. Now putting all the values, we will get phi ABCD as 3q upon 160 pi epsilon naught, and as per the question we are supposed to find n and m. This one was our format, right? Q by 80 pi epsilon naught times n by m. So n is 3 and m is 2, so n plus m is 5, and that is our answer for this question. I hope it's clear. So that's all for today, and thank you. Stay tuned for more interesting problems.